So, good afternoon everyone. My name is Matthew Jones. I'm from Aberystwyth University and I'm based in the Institute for Biological, Environmental and Rural Sciences, which is better known as IBIS. So for those of you who don't know, IBIS is the largest agricultural department in the UK. I am one of 300 staff and there are 1,200 students in the department, and we only income about £24 million a year. With £17 million of that coming from research. So my role is as a research development officer, so I'm not necessarily a researcher, but I am involved in developing consortia and assisting academics with putting together research proposals from sort of the concept idea to final submission to people like the TSB. Excuse me. So IBIS is geared towards addressing the global grand challenges. So with that, I mean living with climate change, renewable energy, global food and water security, and animal and plant diseases. So IBIS' research structure is split into 3 themes, as we call them. So I'm involved in the animal and microbial sciences theme. We have a genome diversity theme and an environmental impact theme. So even though these exist as an entirety on their own, they do work in collaboration to address the grand challenges such as food security, bioenergy, biorefining, and mitigating climate change. So I just thought I'd put the topics that each theme work on, just in case anyone's particularly interested in any of these. So these are, we've got academics working in each one of these themes, so they're not necessarily people who would be automatically looking at agri-tech for a source of funding. But if there was anybody in the audience that's interested in hooking up with somebody who does research in this sort of theme, please come see me afterwards. So like I said, the 3 themes, so the topics involve sort of a lot of animal research, so animal systems, parasitology, so a lot of the diseases associated with agriculture, diet and health is quite a big one. But also, as I mentioned in the next slide, we deal a lot with plants, the genome diversity of plants, so the biology, the plant breeding aspect. We have quite a large biorefining institute called Beacon, which I'll briefly discuss in the next slide. How am I doing for time?
2 minutes,
2 minutes. So, yeah, just the environmental impact theme is very prominent and sees a big opportunity in agri-tech. So, it's very difficult for me to explain IBIS in its entirety in 5 minutes. So what I thought is I'll put in a few things that we're working on in particular that has a significant overlap with the agri-tech. So, first of all, I mentioned we'll get an innovation campus. So this is a scheme that's ongoing now where we're going to develop an innovation campus which is geared to being a hub towards developing high quality fuels, foods and biorefinery. And this is supported, well, we're looking to raise £35 million to develop this in its entirety. We've already received £14.5 million from the SRC. And we're working with the government to secure the rest of this funding. Food playground is a very interesting one. I'll briefly touch on that. So this is a Upland Research Centre just inland from Aberystwyth actually, and it was previously run by ADAS as a research farm, and we've now taken on the lease. It has a huge area that we have at our disposal, and we put one proposal in for agri-tech, utilising the land. So we have about hundreds of acres of land here. We're looking to utilise this land in collaboration with partners for agri-tech. Briefly, I'll touch on Phenomic Centre. This is, what you can't see here is a massive greenhouse, about 3 tennis courts of size. And here we can put plants through automated feeding and watering to develop, to find out what the best conditions are for growing plants. Plants and oat breeding is huge in Aberystwyth, so what you might not know is 65% of the oats that are grown in the UK are bred in Aberystwyth, and the plant breeding links in Beacon, which is involving extracting natural products and cosmetics and fuels from plants. And we have a huge link with the Centre of Excellence UK Farming Futures, and the organics into Wales. Everybody's interested to come and talk to me, of course.
My name's Bob Lovett, I'm from Swansea University. I also represent Membranology, which is a small spin-out company from the university, and the aim of that company is to develop and market our expertise in membrane systems. The university basically has a long legacy in membrane technology. We're basically chemical engineers, and we've applied membranes to a wide range of biotechnical applications. We've got we've got a series of pilot plants that can move around. Mobile, we've taken them to India to refine tea, extract tea from, or compounds from tea and things like that. And we've got a wide range of expertise in membrane fabrication, membrane characterization and selection, which is very important if you want to do this sort of processing. We've got a lot of expertise in water processing, membrane bioreactors, downstream processing, and so on. There are a range of those who don't know about microfiltration or filtration processes. There are a number of filtration processes classified according to this method, basically microfilters, ultrafilters, nanofilters, and ultimately reverse osmosis. And each one of these cuts off a different size particle from the solution. So by judicious use of these techniques, we can basically refine a large number of materials from biological sources. We've mainly been involved in food and fermentations, including things like organic waste and dealing with organic waste and things like that, and isolating metals and salts from waste materials. The two main areas in agri-tech that we're involved with is fine chemicals from waste, and here we're looking at colours, flavours, antioxidants, antimicrobials and things like this. And we've got a number of projects which we've carried out in this area, and most of it is dominated by the use of what we call nanofiltration. And the nanofiltration is a filter which will effectively isolate molecular weights below 1,000, above 200, that sort of range. And there are a number of very interesting chemicals in that we can use. The nanofiltration membrane itself is, the forces involved in the separation are not purely size. There's a lot of interactions with the surface and the particles that you're trying to isolate, and the college science of that process is really important if you want to achieve your separations, and we've got all the basic methodologies for doing that. Some examples of what we do in this area is we do waste potato skin processing, where we're taking out compounds called castogenes, minor sugars. We're looking at water-soluble pigment extractions, anthocyanins, for instance, a range of protein and peptide extraction methodologies, and basically things like that. The other area that we're involved in is the valorization of aquaculture and AD wastes. And we've got a range of membrane technologies we've applied to these problems. Growing algae, harvesting algae, things like this. The idea of formulating nutrients from wastes for useful products, things like growth media for microbes, so we can take anaerobic digestate fluids, formulate them correctly, so we can then use them as a raw material for growing fermenting various materials. This has led us into things like PHA production from anaerobic digestive fluids, fatty acid isolation, and so on. We're also interested in these important nutrients here, DHA and EPA, which we grow in algae, but you can also basically formulate waste and then produce these materials using algae. Okay, I'll finish there, thank you.
ladies and gentlemen. I'm Roelof Kramer, Rectory Farmhouse. We do business consulting services. We is mostly me. At the moment, we are busy with a growing decision support system, how to better collect, process, and analyze data, improve crop profitability. What we are doing at the moment is developing a crop growth measurement system. I'm doing that now together in a feasibility study funded by the TSB with British Sugar and Rectory, a software company. The objective is to analyze which variables are having an effect in interaction and which ones are very important for the crop growth. And we try to combine that with a modeling, mathematical modeling. By mathematical modeling and calibrating the results with crop measurement data like canopy, emergence and yield, we will be able to improve the forecasting capacity of the model. And once we are able to identify the effects and the factors that influence crop growth very much to a certain certainty, we can add value-added modules. Value-added modules like decision support systems for farmers, also for gap analysis and investment decisions for the future, because crop growth is very difficult. For example, in an oven you can have a cooking process where you can control all factors and variables. Crop growth is more difficult because you cannot control the weather and the soil quality, not for in the short term. So we are able in the future to filter out the background noise and pinpoint exactly which factors we can tweak about in order to improve crop productivity. As I said, we are doing the feasibility study. The challenges in that are that we are looking for data which is important, which is also affordable to measure. And the other challenge is to optimize the mathematical model. And the last challenge is to see which data in crop scouting we can reliably measure, like emergence and yield. So Rectory Farmhouse is passionate in sustainable intensification of agriculture. We know that big data processing and mathematical modeling will make us a step further in order to better use precision farming, genomics and all the other factors that everybody's talking about, but also is able to integrate this and optimize the influence. We have an international network and market knowledge, so any field we develop, we also foresee a market in abroad, and like in developing countries where we are going from extensive to intensive agriculture, we can use this method very well. What are we looking for? On one hand, we look for growers or processes that are vertically integrated, that have a specific problem for which we can design a tailor-made crop measurement system. We're not thinking only about sugar beet, we think about vegetables, potatoes, oilseed rape, because we would like to have this model working for all the crops in the rotation scheme of farms. The grower processor groups need to have a problem that it needs an integration solution in a complex environment, hence our measurement system, and interest in sustainable intensification or smart farming. On the other hand, we look for technology partners so that we can more affordable and accurate measure the data that we want to collect for the system. We want to see in mathematical crop modeling in order to optimize the mathematics. On the other hand, crop scouting technologies so that we can easier identify emergence, canopy development, yield, quantity and quality, because it has to be manageable, all the data. Thank you very much.
Good afternoon, ladies and gentlemen. I'm Ivan Williams from Promo International. Apology, David Cook couldn't be here today. My role within the company is I manage business in Wales for them. In terms of the business, who we are and what we do, we are a team of 100 consultants and advisors. We're in fact working not only in the UK but across obviously the entire globe. We've got experts in technical and farm consultancy, agri-food. It's the agri-food that are mainly the international sort of consultants with us.
They're obviously in China, they're in India at the moment, and the reason for that is our parent company is Genus PLC. Many of you know Genus. Again, it's one of the growth areas for us at the moment, PIC in certainly China, and also dairy development in India. And many of our consultants are obviously involved with that business over there. In terms of our headquarters in the UK, we have global reach, as I said, and we've been 2013 working in 40 countries across the world with our consultants. So in terms of exposure, linking with a company like ours, obviously you will have exposure across the entire globe. It's a division of Genus PLC, a FTSE 250 company, and core business includes Genus, ABC, PIC, and Proma Consulting. I belong to Proma Consulting, and that's the reason I'm here really, because a number of people and businesses in the UK don't really know Proma as part of a Genus company. And as I said, we are the biggest in the UK agri and agri-food consultancy company in the UK. And we've got access to just under 15,000 farmers in the UK that we work with. So in terms of exposure with primary producers, our company probably is one of the biggest in the UK. In terms of expertise, we have 3 divisions of consultancy. If I start on the farming side, we provide technical support for farmers, just under 100 consultants out there. They're at farm drives every day of the week. We also have a business support for farmers, which is a farm secretarial group. We've got farm secretaries going up drives, and hence all the financial data we have. We do all the benchmarking, etc. for farmers based on accounts. And some of you may have heard of Tesco, the cost tracker. Tesco have pledged they will pay a fair price to farmers for milk. It's Proma accounts that actually do that. We do that in-house as part of our business. And also we do farm business accounts to farmers, so that at the end of the year, obviously it's used by accountants as for tax accounts purposes. The agri-food, we have another division. They're based in the projects team, the same team as I'm in. I work in the agri side and the agri-food specialist in terms of agri-food research and consultancy. We go across the entire value chain from farm to fork. So you may have heard of our head of director there, John Giles. He's quite often on platforms. He heads up the agri-food. And we're focusing on delivering client solutions, basically. So, in fact, in Wales, we do a lot of work with the Welsh Government. We also do a lot of work for retailers, as I said, across the whole chain. Environmental sites, again, it fits in with our business model. We provide farm environmental services on farm. We do carbon footprint work for a number of retailers, and especially milk buyers. The milk buyers being part of Genus, they're quite interested in the carbon footprinting with us, so hence this division has focused very much so on that area of work. And also resource efficiency advice. Obviously the primary producers need to obviously get involved in that area. We've got a team of staff that actually help farmers on that side. And we're also getting into training and development work at the moment with a lot of leadership training courses. So in terms of exposure, my pitch is, if you want exposure to primary producers and retailers, not only in the UK, but across the entire world, Proma International, please get in touch. Thank you.
Yes, good afternoon. I'm Kate Wilkinson from the Food and Environment Research Agency, more commonly known as FERA. We're a UK government agency, part of DEFRA, but as you'll see, we have more and more customers now who are nothing to do with the UK and nothing to do with government. So I'm here today really to tell you that we're out here willing to work with people from all sectors. We're celebrating our 100th birthday this year, although FERA itself is not 100 years old. Our predecessor organisations, we can date back to 1914. They were mainly concerned with food security as land use was changing and we were gearing up for World War I and looking to increase crop yields. And also as the Victorians began to wander around the globe and bring plants back, there was an increase in the need for plant biosecurity. And our main aims these days, although the reasons behind them have changed, they're still the main aims of our organisation. We're used to working in big collaborative projects, and we've been successful in winning TSB calls in the past. We're currently working on 27 million euros worth of EU funding, and our biggest project that we're leading has 38 partners in it, so we're used to working in big collaborations. We pride ourselves as a quality organisation. We hold ISO accreditation for our environmental systems, management systems and laboratory systems. We're an International Seed Testing Association and National Plant Protection Organisation accredited organisation, and we're also the National Reference Laboratory for much of our food contaminant work. So to give you a brief overview of all the different things that FERA do, we're broadly divided up into 6 categories. Our Centre for Chemical Safety and Stewardship is concerned with ecotoxicology, environmental and human exposure work, and that together with the analytical chemistry capability means we can assess and minimise the impact of chemicals in the environment. Our surveillance and detection technology for pests and diseases. We have the largest group of applied plant pathologists in the UK, so we have capability in bacteriology, mycology and virology. Our plant clinic provides our commercial service to growers who want quick identification of their pests and diseases. And we're also the global leader in new threats and diseases, and we were the lead on the recent ash dieback, the cholera incident of the government. We're also working in the field on handheld devices such as lateral flow devices so that you can get quick identification of the pests and diseases. You don't have to wait for the samples to be sent back to the laboratory. Our agri-tech team are involved in mites, insects, slugs and nematodes. They're looking to detect and identify them both in growing crops and in crop storage. And also then looking at novel ways of controlling them, so biopesticides and that sort of thing. Our food offer, we're looking for biochemical and chemical constituents of food, both the things that you want to be there and the things that you'd rather weren't. We can look at detection and identification of these, and also the authenticity and origin claims. So we were recently involved in the horse meat scandal to authenticate where all the meat had come from. Our Agri-Food Resilience Centre is a joint initiative with the University of York, and that's focusing on food and non-food crops for food security and environmental sustainability. And our crop health offer delivers integrated solutions to safeguard crop yield and quality. That's both arable and horticultural crops. So basically I'm here to say we're not just a government agency, we don't just do work for government, we're happy to work with partners across academia and commercial sectors. And hopefully we'll be able to find some people to work with so we can put some bids in for TSB this year. Thank you.
Good afternoon, my name is Alex. I'm a lecturer at the University of Manchester. I'm going to present some of the specific skills and technologies that we have available within the university. So starting with myself, my background is all in precision monitoring. So this typically involves dealing with signals in the microvolt range or sub-microvolt range or microvolt range, or with currents typically in the nanoamp to picoamp range. Collecting and dealing with those involves creating fully custom instrumentation, typically at the custom ASIC level, and there are some example pictures on the bottom here of microchips that we take out for the collection and processing of these very small signals. Those microchips themselves tend to consume very little power, typically in the microwatt and lower ranges, and we're increasingly looking to use energy harvesting as a power source into our precision monitoring systems, so we can extend battery life and increase the level of miniaturization that we have. The converse to that is, into our centres, we're also introducing more signal analysis and automated data reduction algorithms, things like automatic event detection, so that we can intelligently turn on and off transmission again, saving us power, increasing the amount of monitoring that we're able to do. These are all very small signals, and so several of the algorithms now are using what's called noise-enhanced techniques. So we're dealing with very low signal-to-noise ratio situations, but if we design our algorithms appropriately, we can make use of stochastic resonance effects, and actually our algorithms get better performance as more noise is present in the system, not worse performance. And that opens up a lot of new design opportunities. My background, as you can see on the very right here, is actually in human monitoring and applying these to wearable sensors. This is for neural monitoring in this example here. And I would be keen to work with people in other application areas, in livestock or in crop monitoring, to take some of the skills and technologies that we've developed for precision monitoring into some of those application areas. More generally, I'm part of the Sensing, Imaging and Signal Processing Group at the University of Manchester. And we have a major research theme on e-agri. And this is a holistic theme aiming to connect some of the technologies that we've developed in terms of sensors to applications in terms of livestock and crop monitoring, together with skills in ICT, big data. Specific technologies that we have are in tomography, for example, electrical impedance tomography, putting wires into the soil and using tomography to monitor root networks. Hyperspectral imaging, as we heard a little bit about before, and of course combining that with autonomous systems, both flying-based ones and rover-based systems. And then RFID tagging and sensor networks in general, dealing with having tens, hundreds, thousands of sensors as part of our system and dealing with the data that we collect as a part of that. So again, this is some examples of the kind of technologies that we have developed and are available in the University of Manchester, and we'd be keen to push out into more application areas. Thank you.
My name's Andy Waller, I work for Lockheed Martin UK. Lockheed Martin are probably best known as a defence company, and we're the world's largest defence company, but we also do a lot of things in civil domain. And in fact in the UK we've got about 3,000 employees spread across 12 locations, and some of the things we do in the civil domain include working in air traffic control. We do all the air traffic control management. We work with the Ministry of Justice and do the IT for them. We do all the back office stuff for the Royal Mail. So do quite a lot of things in that domain. But really our specialist areas are systems integration, IT, and some airborne products, and also simulation. So some of the things that might be of use for you, first of all is the unmanned air vehicles, like Cal and Lens do. We've got a full range of small products, the sort of quadcopters, so they're helicopters which have got 4 rotors, and they can hover very precisely over a field, and you can stitch that all together and you get very accurate measurement of crops, and you can get that to centimetre accuracy. And we can do that with stills imagery or infrared, or you could also do hyperspectral if you want to measure nitrogen levels in your soil, or you want to detect crop diseases early, degradation of crops. So we've got that in a quadcopter, but we've also got a larger size which is hand launched and can carry bigger payloads and can fly for a longer period of time. So that's one side of the things that we do. We've done that with some agricultural companies in the US. So we're looking to do some stuff in the UK now. We also do stuff on the IT side, so big data, looking at big networks of sensors, and managing those networks of sensors. So all these things that we've been talking about with sensors in the soil, sensors on vehicles, on tractors when they're gathering data, or in cows or whatever, and we can pull it all together and fuse it and make it into usable information. but we don't have the expertise how to interpret that. So we've got all the tools to help you do something. It's just we need experts to help us turn it into a useful product. The other thing we do is on simulation. So we do a lot on simulation in the civil domain. So if you want to do farm simulations and doing predictive analysis, then perhaps we can help you on that as well. So these, we're not really experts in the agricultural domain, so we're looking to partner with people that are. So that's some of the people that I thought might be of use. We're looking to really go to the industrial research side. So if you want to do field tests and things like that, then please come to speak to us. Okay.
We've had the high tech. That's all about to stop. Welcome to Pierce Seeds. I'm Paul Taylor, General Manager. We're a privately owned company focused on the requirements of livestock and arable farmers in the south and west of England. We've a turnover of about 20 million. And our customer base is predominantly mixed and livestock farms with a particular focus on dairy. I say dairy because there's about 900,000 cows in our area, 43% of the English herd, and 38% of the beef and 30% of the sheep. That's from DEFRA Statistics 2010. Our core activities, agronomy and supply of crop protection products, seed production, arable, grass, forage, organic and conventional, on all of those. And we have a trials facility, we have a trials farm of 180 acres based at Sturmston Newton, doing chemical and variety trials replicated to CRD and recommended list of protocols. So what we want is to increase the quantity and quality of home-produced feed for the livestock sector in our area, in order to reduce the unit cost of production of milk and meat, and particularly vegetable protein, to decrease the dependence on brought-in feed, and thereby decoupling production from commodity prices. We also want to manage risk with a greater variety of feedstuffs. In the case of the poor season like 2012, where maize and wheat just didn't produce. And being more self-sufficient, livestock farmers will have less risk of a feed scare with things like lead and dioxin in feed. So what Pierce Seeds can offer is, first of all, customers are asking us to do this. So we will be doing some of this work anyway. It's just the degree of funding we extend to the work that we get involved in. We can offer the use of our own trials facility, both on organic and conventional land. We have a sales force of 18 agronomists on farm, so we can have on-farm experimentation and evaluation. We have extensive connections with plant breeding and agrochemical industries, and so we bring new products forward, and particularly new products such as the hybrid rice, energy beets and things that have been developed for energy generation, which have a direct read across into livestock production. We also have 50% of our business is wholesale, so there are networking opportunities with like-minded arable companies. What we need are partners with expertise in ruminant nutrition, for the analysis of forage quality, conversion rates and improvements, what the novel products will bring in terms of milk and meat production, and costings on those systems, and also people with insights into machinery. We're looking to optimise establishment, seed rates and seed beds, so using modern techniques of establishment in these more traditional crops. And also looking for financial expertise, the costing of fixed costs over a rotation, so the effects of changing the cropping pattern on labour requirements and machinery usage. And hopefully the outputs of this will be we keep the family farmer farming. 37% of all farm labour is employed within our trading area. Hopefully to stabilise and lower cost of production, less linkage to commodity prices, and stable domestic and milk and meat prices. Less use of intensive inputs such as fertiliser and chemicals, and better land utilisation to reduce soil erosion, capturing sunlight throughout the season. And these solutions must be robust because livestock farmers are always busy, and time limits will not always be their strength. So if you feel that you can join us, please contact me afterwards.
Hello there, I'm Nick Hodges from the Robotics Lab in the Mechanical Engineering Department in the University of Bath, and I'm just coming to speak to you about a new computer vision and perception algorithm that we have in the pipeline there, which will be of particular use for many automation tasks. Quite a lot of tasks in agriculture and food production today still require quite a lot of human input. There's already machinery, but it needs to have human operators because you need somebody that can see and understand what you're interacting with, whether it's picking fresh produce, operating tractors and so on to move stuff, load stuff, and so on. You need to have somebody that understands that the bale has weight, it's deformable under load, so when you stack them on the trailer, they don't just stack neatly like blocks, they move and deform. The existing computer vision tends to require everything to be nice and rigid, and that just doesn't work in there. Likewise, many livestock handling, again, at present needs a person to see the animals, even though the tasks may be actually very simple and straightforward. What we have in pipeline is a real-time visual spatial perception system that actually models the physical structure of what we're seeing, can cope with non-rigid materials and fluids and so on that the previous algorithms haven't been able to deal with. Applying this to automating machinery, be it vehicles or fixed machinery, means that you no longer have to have human operators in so many places. So you can have smaller, lighter, cheaper machinery or increase the productivity from existing machinery because it can work 24/7. To give an idea of how this works, it hasn't just appeared out of nowhere. Text straight there. Okay, at the top there you've got a picture of an existing state-of-the-art computer vision algorithm. That is the image it's looking at, and then this is the dense depth map it's able to generate. The catch with this existing state-of-the-art system is that it depends on the rigid world model. Now I did have a picture here which showed you what a smooth particle physics model looks like. It seems to have been eaten by the slide somehow. But coming from the simulation technology side, both engineering simulation and video game simulation, our ability now to simulate fluids and deformable materials and so on is much better than it was in the past. Plus the very much cheaper computer graphics hardware is very, very fast now. Means that what was never possible before becomes possible. We combine the ability to simulate fluids with the ability to extract surfaces and then model deformable objects, fluids, so that if you are handling these materials either in your food factory or with agricultural machinery, you can have a computer system that understands it and can therefore automate that process for you. At the moment we have a biomedical sponsor that is funding the non-real-time version of our system. Basically we're looking for partners to help us get funding for 2 more PhD students to produce the real-time version of the algorithm, potentially for an industrial research award project. There are also, not mentioned before here, EU Horizon 2020 calls which would be applicable as well. That's
Okay, hello everyone. My name's Vanda McCormick. I'm from Moulton College. I'm the Senior Lecturer in Animal Welfare and Management there, but I have overall remit for research and technology transfer, so I'm kind of wearing several hats today. I'm here in favour of not only the animal production and livestock side of things, but also horticulture, arboriculture and crops. So I initially just wanted to kind of give people an overview of the college, because it's not necessarily very well known outside of Northamptonshire and the surrounding counties. So originally we were the Agricultural College of Northamptonshire. Moulton College is now a land-based college where we do both further education and higher education. And we very heavily rely upon commercial farming enterprises to underpin all of our teaching. And over the last few years we've really been developing more into the research side of things. So all of the land that we have, the 485 hectares, are farmed commercially as independent businesses rather than as kind of model systems. So they're under all of the market trends that everything else goes under. So the idea is that we have several different sectors. We're mixed livestock and arable. Our dairy unit, we have at the moment around 220 cattle milking, normally 250 Holstein Friesians. Managed as 3 distinct milking groups, so we, according to the lactation cycles, we've got fresh calves, highs and lows. And we're milking twice a day, currently moving into 3 times a day for our highest yielding cattle. The herd calves all year round, and our breeding emphasis is on phenotypic traits such as fertility, type traits in legs of feed, production traits, so milk yields and other aspects. We currently have a kind of a system that's adopting fertility performance with cows being mated through a programme that prevents inbreeding, maximises genetic gain. And we own a 3,700,000 litres of wholesale milk quota at 4% butter fat, with milk directly marketed to Arla Limited on an online contract, being collected every second day. We rear all of our own replacements within the college facilities, so our calves are removed from their dams of birth and penned separately, then transferred to our young stock unit, which runs alongside with the beef production. They're transferred into our heifer groups, and the heifers are then served 14 to 16 months by AAI, and we have an Aberdeen Angus bull who acts as our sweeper for those that are delayed bullers. So we then keep those crossbreed continental calves through for beef production at grass and just bringing them in for finishing in the yard. Our heifers we're then selling at dead weight if they're from the crossbreeds to a number of different abattoirs, and the college is accredited under the Farm Assured British Beef and Lamb Scheme. In the lamb production side of things, we have a flock of around 1,000 North Country mill ewes with a dozen or so Texel rams, 10 pedigree Suffolks and a couple of other breeds that we're using. And our flock lands predominantly in March, with the ewes being moved in 18 days before tupping to flushing pastures. March lambs are mothered with their lambs for 36 hours, then turned out to grass, and our lambs are sold off grass between June and early August. Any that aren't sold are then stored at grass and sold further on into the autumn to abattoirs. And again, we've got the Farm Assured British Beef and Lamb Scheme there. Alongside our livestock production, we do have arable unit, so we're operating a mixture of cereal, oilseed rapes and forage-based rotation systems to optimise the area of first-row wheat. And we are marketing our crops to a variety of different merchants, including Nadero, Frontier Agriculture, Charles Jackson and United Oilseeds. And again, we're part of that Farm Assured combinable crop assurance. The last kind of aspect that kind of touches into this sector would be our horticulture, which we actually run a commercial garden centre within the premises. We have glass houses and special plant nurseries in various aspects, as well as areas around the estate for tree production. Now, in terms of how we've been developing into research, initially we've been doing this through the use of PhD students, and we have PhD students crossing a wide variety of different areas, some of which I'll mention today, but also in other areas such as our domestic animals and equines. Within the dairy sector, we've had a student who's been looking at social bonding in dairy cattle, and the idea of having support groupings in a dynamic system, so actually to avoid the stressful kind of situations. The idea being to look at ways to manage the groups more stably without regular changing of animals. In the sheep area, we have 2 PhD students, one who has now completed, who's been looking at the impacts of fostering on welfare and meat production systems, and actually has effectively come down to the fact that the fostering is always preferable to the meat production. We've also got somebody looking at epidemiology of ORF within sheep. We have agri-environment students looking at a couple of different aspects of ecological networks in terms of managing protocols for agri-environment schemes. We have agronomy projects that have just started in collaboration with Cranfield University and Frontier Agronomy, looking at minimum tillage systems. And we've got 2 projects ongoing in horticulture as well, looking at methods of promoting adventitious rooting in fruit trees, and also looking at novel green manure as soil steriliser. And I mentioned we've been starting to develop the research, and we've been doing small-scale kind of commercial trials with various industrial partners, including animal nutrition companies, bioelectrical impedance analysis things. So really what we're looking for is partners who would like to join in with us in a collaboration. We have commercial resources and we have experience of running smaller-scale commercial trials, but we're looking for people who might want to kind of join in on the larger-scale projects with us.